Hello everyone, I am Kavish Viltharia and I am here to discuss uh, the and some examination of data science. And let's start with the question one. Now, question one talks about hypothesis driven versus data driven paradigm. We would take illustrations from IPC and BNS procedures, which are latest which are recently introduced in Indian law system. So uh, let's start with question 1A. We are asked to distinguish between two fundamental approaches in data science. First, we have the hypothesis-driven paradigm. This is the traditional scientific method. You would start with a human assumption or a theory, and then you go out and collect data specially to test it. For example, in a crime scenario, a lawyer might assume if a marriage is less than 7 years and then there is a burn injury, it's a dowry debt. They only look for evidence that fits this narrow view. Contrast this with data-driven paradigm. Here we don't start with a rule. We feed massive amounts of data, say 50,000 FIRs, into a machine learning algorithm. The model might discover a pattern we never thought of, like dowry demand plus a suicide note equals a 97% conviction rate. It generates new insights rather than just testing old ones. Moving to question 1B, uh, we look at the four main types of data we encounter: structured data, unstructured data, quantitative data, and categorical data. Structured data is what you see in Excel or SQL, highly organized rows and columns. Think of an FIR table with columns for case ID and age. Unstructured data. It has no predefined format. This includes the scanned handwritten pages of a police report or video files from student assignments. Quantitative data is numerical and measurable. Examples are the number of injuries or a student's test marks, like 24 out of 30. Categorical data represents labels, for instance, the relationship field in a database, husband versus in-laws, uh, or a student's branch, CSE versus MTech, mechanical, sorry. Then for question 2A, we apply Bayes theorem for decision making. This theorem allows us to update the probability of an event as we get new evidence. Let's look at the student example. We start with a prior probability. We know 75% of students pass or 25% fail. We get new evidence. A student has low attendance. We know that 85% of failing students have low attendance compared to only 15% of passing students. By plugging these into the formula, we calculate the posterior probability, even though most students pass generally. A student with this specific attendance record has a 65% risk of failing. This quantifies our risk. Now coming to question 2B, which asks for association rule mining algorithm. The goal here is to find if-then patterns, like if a student fails test 1 and the quiz, they will likely fail the answer. We will use the a priori algorithm. It works in two main phases. Generate a frequent item set. We scan the database to find individual items that appear frequently enough to meet our minimum support threshold. Iterative join and prune. We combine these small items into larger groups. pairs, triplets. If any subset of a group isn't frequent, we prone or discard it immediately to save computing power. Finally, we generate rules from these groups that meet a minimum confidence level. Now coming to question 3. In question 3a, we analyze a small data set of student marks. The mean is 13.5. This is the arithmetic average, but note that it's pulled down by the lower scores. The median is 12. That's the middle value and often gives a bigger picture of the typical student uh, because it ignores outliers. The mode is also 12, the most frequent score. Crucially, the standard deviation is 7.2. High standard deviation tells a teacher that the class performance is spread out widely. The batch is very uneven. Now, question 3b deals with the data quality. We must distinguish between errors and artifacts. An error is a mistake like a typo, entering age 150 instead of 50. An artifact is a system issue in the data collection process itself. For example, if all crime scene photos are overexposed, that's not a typo. It's an artifact of the camera or lighting used. To fix missing data, we can use imputation. A simple imputation fills the gap with the mean or average. A smarter method is k nearest neighbors, KNN, where we find the five most similar students and copy their data to fill the gap. So imputation techniques are done. And with this, I would end this video. From the next video, we would continue the question 4, 5, and 6. The total number of questions in this and some examination are 9. So we would have two further videos for that. And thank you so much for watching this video. Uh, Thank you so much.